It's a pleasure to join you all. I've been working with Gulf Coast Authority for about 8 years. I'm a graduate of U of H Clear Lake. I received my bachelor's in biology from U of H Clear Lake. I'm a big fan of the campus. Additionally, we do tours with U of H Clear Lake. We sometimes work with Kathy Garland, who I know was a presenter earlier today. She'll occasionally have her environmental students come out and get a tour of our plant. We also work with middle school and high school students to tour our facilities. So we always like to give back, and I've actually been looking forward to doing this kind of thing. So I'm very happy to be here. I'm also working on my MBA from Rice University. So I'm still in that grind of schoolwork and education, and I can understand you all here and your students. So, and the topic today is wastewater treatment. Well, here we are, we're Gulf Coast Authority, and I'd like to speak about the purpose of wastewater treatment and wastewater management. Obviously, it's to protect the public health. Gulf Coast Authority was created by the state of Texas to protect the waters of the state of Texas. And we had the unique ability to build and make regional wastewater treatment plants, which means we can combine multiple cities and municipalities, mud districts, industrial wastewater plants, in one collective plant. For example, our Bayport facility has 83 different industrial wastewater streams. The facility I'm at has 4 different participants, being 2 cities and 2 mud districts. We also have 3 other plants that are collectively treating industrial wastewaters. So we have the unique ability to write permits and hold the users accountable rather than those users going through TCEQ. Part of the wastewater management purpose is to reduce oxygen demand. As you may know, lower DO in the receiving stream can cause fish kills, and it's harmful to aquatic life. So our number one concern is that aquatic life and the environment of the receiving stream. So with our wastewater treatment plant, we remove organics from the waste. We oxidize ammonia to nitrite and nitrate, and the bacteria is removed before discharge through disinfection. And we have multiple ways to disinfect, and that's our final treatment process. And we're beginning to have more and more regulations with new criteria that needs to be met in coming years. So that will potentially add more treatment processes. So to start with the fundamentals of wastewater treatment, in a regular municipality, we have our collection system. So that's the sanitary sewer line that runs underground. And we have several connections coming from houses, commercial units, as well as industrial and any site that you may think of, your houses, the car washes, the malls. They have a gravity sewer that runs to either a force main or another gravity line. So these sanitary sewers, the pipeline usually runs via gravity to a lift station, which is a large sump that'll have multiple pumps that lift that water from the lowest elevation. It lifts it to a higher elevation. That way it can ultimately gravity flow through the wastewater treatment plant. So this is the initial part of the treatment. No treatment actually occurs here. It's just the collection system to get the wastewater to the receiving plant. So here we have what is called pretreatment. And this is where we have raw wastewater, and we'll try to take out some of the inorganic materials. So things that you can imagine, debris, any sort of logs or plastics, any material, beads, any sort of thing that may enter your collection system that can be removed via screening. So here, this is actually a picture of our wastewater treatment plant that has 2 bar screens. If you remove those covers, there's these 1/4-inch screens that keep all the rags and other inorganic debris out. That'll have these rakes that basically lift up all that inorganic material, and it goes into a conveyor that's ultimately compressed and thrown into a dumpster. So that'll be hauled on a weekly or bi-weekly basis. So the purpose of this is strictly pre-treatment. We're not into the biological or any other treatment process here. This is just removing materials that can cause issues to our pumps and other processes. So here, the pre-treatment, again, we have screening of inorganics, and then issues that we've been having as of recent that has been one of our main focus to educate the public is things like baby wipes. Although they're said to be flushable, they cause many disruptions downstream. So they may be able to enter your gravity mains and your force mains, but when they get through to the screening process, they can cause lots of issues as well as through the pumps. So things like the coffee grinds, your bacon grease, the fats that may be poured down the drain, and primarily the baby wipes will come in and they'll clog the pumps and they'll get stuck in the rotating assemblies. And that's been our main driver for maintenance and cost at the wastewater treatment plant. So if you speak with your students, that's one thing that I always promote mentioning is that baby wipes, although they say flushable, they can cause millions of dollars worth of damage. And we've seen that at many places like in New Jersey, city of Houston, all throughout the nation. This has been a big dilemma that's, there's been lawsuits out, there's been a lot of activity here to prevent that. So in our treatment plant, we have this yellow box of our Headworks. Basically, we have off-site lift stations that'll lift the wastewater from a lower elevation spot up to the Headworks, which in this case is about 25 feet off the ground. So it pumps to a sump that's elevated, and from there it'll gravity flow to the other stages of the plant. And the reason we want the gravity flow is to minimize the need for pumps or backups or other issues that may happen. So next we move on to the biological treatment. This is basically the heart of the plant. This is where the majority of the work occurs by our microorganisms that are found naturally occurring in our intestines and are naturally occurring in the environment that we're providing. Basically, our goal is to provide enough oxygen, the correct temperature, and enough nutrients to keep the healthy bugs alive and consume all the organics. So next slide, we have the aerobic biological organic removal. So our goal here is to provide the bacteria with organics that we're sending in the raw wastewater, and we provide oxygen and the naturally occurring nutrients. Some facilities have to supplement nutrients if they don't have enough ammonia or other materials. They have to supplement with nutrients in some form of acid or just direct ammonia injected into the raw wastewater. So here what we have is bacteria, carbon dioxide, and some leftover organics. We're required to treat to a certain limitation. There will always be some leftover. Ultimately, our goal is to minimize the strength of the wastewater and to remove any fecal matter or bacteria that may cause harm to the receiving stream. So next, the activated sludge system. All of our plants are activated sludge plants, meaning that the raw wastewater is mixed with return sludge. So all the sludge that we settle out, all the bugs in the water, we'll ultimately settle them out, and a portion of that gets wasted and it gets compressed. We remove the water out and it either gets hauled or it goes through another treatment process where it gets incinerated and it can be used as fertilizer. But the majority of those solids actually return to the head of the plant and they mix with the raw water. So this can seem abnormal, but essentially we're returning the healthy bugs to the raw water so that it can consume the raw water. And at times, if a wastewater treatment plant has a bug kill, they'll actually go to other treatment plants and ask for their bugs, for their sludge, in order to reseed their plant. So there are situations where you can have a bug kill, usually from a slug of some sort, where it could be fuel or high organic loading or any sort of industrial materials that cause death to your microorganisms. So it's a very finicky process where we want to keep our healthy bugs alive. We want to keep basically our middle-aged bugs working hard. If they're too young or too old, then we'll have issues with treatment. And then we'll discuss a little bit later about how we test our sludge to see the age of the sludge and how well it's working. So here, this is the heart of our plant and most of our plants for the authority. We have a secondary treatment process. So our aeration basins are the biological process. This is where we have the raw sewage mixed with the sludge, and we provide compressed air into the mixture. All of our plants have dissolved oxygen in which we supply air via large blowers. And these, or through mechanical aerators, which are essentially these big motors and gearboxes that are attached to a large fan blade that causes a mixture and dissolves oxygen into the water. But newer technology includes blowers that supply piping into the basin and provides compressed air. Some of our plants also have direct oxygen line. And then our goal is to also provide mixing. If you have dead zones, you can have septic sludge, and you can have foul odors and other issues. So it's really important. If you do not have a good blower system, then the result will be untreated wastewater. This is I would say, likely the most important part of the treatment process for activated sludge plants. And here we have a couple images of microorganisms you may see. A very popular one is the water bear, the tardigrade. It's been known to be the one microorganism that can make it to Mars and survive on Mars. It's nearly indestructible. It's naturally occurring in our intestines and also seen in our wastewater. So if we collect a sample of our sludge and put it under the microscope, it is likely that you'll run into a water bear, stalk ciliates, and many other microorganisms. So here's a picture of our aeration basin. We have 5 basins here in the rectangle. The front 2 basins, you'll see those 4 squares. Those are mechanical aerators that are mixing the water with those large fan blades, essentially. And then on the back 2 and the front circular one, you can see air bubbling in there, and that's how we provide dissolved oxygen. And to continue the secondary treatment, we'll move on to the physical process. And essentially what we're doing here is providing a circular slope tank that allows the sludge to settle. And then what you see here in the left picture is the effluent water going over the weirs, and this will be further treated. So this clear water is only partially treated, but our goal is to have clarity and minimal turbidity in our water so that we can better treat. At times, if you have an upset in your plant, what you can see is the sludge will belly up, or the sludge will build up so much that it starts to go over the weirs. And when you have those solids that go over the weirs, it'll clog up the rest of your system or not allow your disinfection system to fully penetrate the water and disinfect. So that's a big issue that we try to prevent. And that can be seen if you have major power outages, a bug kill, or equipment that's shut down. So essentially we're working on generating power. Yes, Larissa, question?
So I see all of that is like open air treatment. Is it good when it rains a lot for water treatment plants, or is it not ideal? Like, or does it matter?
Yeah, that's a great question. It's actually our biggest harmful issue for most wastewater treatment plants. It's not supposed to be, because ideally your city has a separate stormwater system, and that does not go to your wastewater treatment plant unless it's permitted to do so, which is a rare occurrence. But regardless, what you'll see is I&I, which is inflow and infiltration, where water will infiltrate the system either through broken pipes or through open manholes or through, gutters that are directly piped into your sewer, which are not supposed to, or just a large volume of rain after the ground gets saturated, it will infiltrate the system. And what you'll see is these sludge blankets and these clarifiers, they'll come up really high, and you'll start to combat that issue. And all wastewater treatment plants will have a maximum discharge limit for the day, for the week, for the year. So, or for a 2-hour period. So rain is one of the biggest topics in wastewater treatment to make sure that we can meet the demand. And also with the cities that we have, they're doing studies to their collection system. They'll do smoke tests to look for leaks. They'll line old collection systems, because as you can imagine, some of these older lines were built many years ago, many decades ago. For example, ours was built in the 70s. So we'll have the integrity of our pipe is questionable. So we'll go through studies, and they're very costly work because you have to work underground. You'll have to close traffic. You'll have to upgrade the piping, and it's a big job. So that's a great question. Rain is definitely a sour subject. But these open tanks is not where we get most of the rain on the surface area, but rather coming into the system. You'll see our average daily flow is roughly 5.5 million. During heavy rain events, we can get to 25 million. So it can increase our flow times 5 or greater. So Hurricane Harvey was a big issue for us because the elevation of our plant and water coming in and the flow coming in. So a portion of our plant flooded. And also when you have these major freezes and you do not have power for extended period of time, you can have a bug kill just from the lack of that mixture and the lack of the dissolved oxygen. And what you'll have to do is remove all that sludge. It becomes septic sludge. So you have millions of gallons of septic sludge that you have to essentially get to the landfill. And that for us took roughly 3 or 4 months. So natural disasters is what to look out for. So post the secondary treatment, not all plants have this, but what we have is tertiary treatment through gravity filters or sand filters, as you would see in a fish tank or aquarium. There's basically sand and anthracite here that takes the effluent water from the clarifier and polishes it through these sand filters. And we'll have these traveling bridges that continuously clean the water. And the reason why we're required to do this is because we have a disinfection system that requires strict clarity in the water. And we'll discuss that next. Here's our tertiary treatment. We have 5 sand filters, and we continuously see evolution of this technology that allows for greater flows and different media, different materials that better polish the water. So we're working on upgrading those because they were built in the 80s and 90s. New technology, you can increase the flow and the flow per surface area by 4 times or 5 times. So my favorite part of the wastewater treatment plant is the disinfection. For me, this is a picture of our plant. We use ultraviolet lights to penetrate the water and basically unravel the DNA of the microorganisms. And this is how we essentially kill the bacteria and fecal matter. Other methods are through sodium hypochlorite and sodium bisulfite. So essentially they use bleach to disinfect the water. And there are also some other disinfection methods. The United States is kind of behind on ultraviolet treatment in wastewater treatment plants, but in other countries, you'll see UV predominantly as their disinfection process. And we're starting to do that a lot more here. This also gives us the capability. This after disinfection will be our fully treated wastewater. And what we'll do is we have the ability to reuse this water as non-potable water for irrigation, or it's reused throughout the plant to wash down areas or supply water to our equipment like our belt presses. And now we're also starting to see direct reuse. So you'll see wastewater treatment plants with a pipeline that directly sends water to a water treatment facility. And that's also something that I look forward to in the future, because we will have strict control of our wastewater that's being sent to the water treatment facility. Currently, what we do is we discharge our wastewater into a receiving stream, and then we pick up from that receiving stream to create drinking water. And you will see actually more difficulty in controlling those parameters that are coming into the plant. It's a big topic to try to get the public aware and accepting of the idea of from toilet to tap, but it is on the horizon. And Texas already has one treatment facility, I believe in West Texas, that is already having direct reuse. So our disinfection is here at the back left part of the plant. And if you can see that long line of water is what's called a partial flume. And after disinfection, it'll go through that channel and we'll test our dissolved oxygen at that point, as well as the rest of the parameters. Our permit limitations are written into a table of our permit. And generally, what you'll see is limitations on biochemical oxygen demand, on ammonia, and on total solids, as well as dissolved oxygen and pH. So those are common parameters for municipalities. In industrial wastewaters, you'll see a very long list of organic compounds consisting of roughly 200 compounds that need to be tested for and analyzed and have their own permit limitations as well. So here, I know your students will be doing a different sort of sampling. So here we have is a gentleman picking up a sample. It's important to read your permit and correctly identify your sample point. Otherwise, this can be a violation by not collecting in the correct spot. Typically, what you'll see is a composite sampler that collects a sample either based on flow or based on time, and it needs to be refrigerated at a temperature of 0 to 6. Or otherwise, what you'll have is grab samples. And grab samples are required for certain parameters. And sometimes those grab samples will be composited for that 24-hour period. And again, some samples need to be refrigerated, some don't. Some have long holding times, like 1 year, and some have holding times of 8 hours. For example, enterococci needs to be analyzed almost immediately. pH in 15 minutes needs to be analyzed. Dissolved oxygen needs to be analyzed immediately. So there's different parameters, different requirements for each testing method and technique. Here are some of the testing that we do on our wastewater. Our DO uptake measures the rate of oxygen use, so our dissolved oxygen. SVI, sludge volume index, that's something we use to detect the settleability. MLSS calculates a number for us to detect how healthy our sludge is and how well it'll thicken. Same with the zone settling velocity, what we typically call the 30 minutes settling test. And we pour up our sludge samples into cylinders and we'll see how it settles, whether it settles evenly, rapidly, slowly. If it floats, that'll tell us the age of the sludge. If it settles rapidly, it's typically older. If it settles very slowly or not uniform, it's younger or could have a filamentous issue. Generally, you want your sludge to settle evenly and you want a sludge of about 300 or 400 milliliters out of 1,000. And then on our discharge permits, obviously any treatment plant is not allowed to discharge without a permit. Here in the state of Texas, all of our permits are through TCEQ and we have TPDES permits. This is why we were created, to abide by these permits and meet the Clean Water Act. Some of the limitations and conditions we spoke about, and our goal is to continuously monitor and report any issues that we may have. We're required to report any issues within 5 days or 24 hours if it meets certain criteria. Otherwise, it would be in our monthly discharge monitoring report. So every month and it's public information, we submit our discharge monthly report with all of our sample analysis data regarding our effluent limitations. So some of the basic functions of a wastewater permit here are listed. There's different levels of performance, and it requires a discharger to report failures. If you're part of any public system, we have online capabilities to upload this information, and we'll send it via email and hard copies as well. And we'll have to notify the public should it exceed a certain volume or a certain limitation. So to conclude, wastewater treatment is designed to protect the public health and the environment for recreational use in the receiving stream. There's different steps to meet our treatment goals, and there's different permit limitations based on your type of treatment plant and what your raw wastewater is. And we're always required to monitor and issue our analysis to the state of Texas. That is it. Here's my name and title, contact information. Should you have any questions, please feel free to reach out.
Can you explain exactly what gray water is?
So gray water is typically water that comes from your showers, your sinks, and all that collectively is gray water. If you have an RV or A lot of some people may separate their gray water from their black water, which would be from your toilets. Also, some nations, they'll actually use their gray water and repurpose it for different reasons, to irrigate, things of that sort. Typically, in the state of Texas, all that water is collected together. So we'll have gray water and black water that's mixed together, and we'll treat both.
Okay. All right. So if you're talking about grey water watering systems, irrigation systems, you're actually collecting that grey water from your own institution. It's not coming, from the treatment plant or anything like that.
It can, that's actually a goal, but it is not a standard infrastructure that's given to cities. So to have non-potable reuse throughout a city, I think there's a lot of regulations that are going in place to allow that, but it's not common practice. Typically, what we can have water reuse for is for agriculture or for golf courses or for certain permitted places, but it's not run to residents.
Is it illegal for residents to use their own gray water?
It is not. You'll see a lot of people with septic tanks that also reuse. Now, I'm sure that's dependent on your area, if you have an HOA or things of that sort. But typically in county zones, you'll see that very frequently. You'll see people that do not discharge to a wastewater treatment plant, and they'll reuse that gray water.
Well, thank you very much for your input.
Absolutely. Thank you all.